Okay, so let me share my screen. So we are starting a new unit today on exponents and radicals. All right, this is lesson 1. So our schedule, we're going to review the homework questions from 7.3 that you guys did. And I saw a lot of you turned it in, okay? And doing that, we're going to review the concepts we learned last time. Next, we are going to go over some exponent rules. So today we are going to be learning about exponents. And next time you're going to be learning about radicals. So it should be a pretty short unit and pretty easy as well. And this will be the last, I think this will be the last unit of this course. So after this, in a whole course review, we'll probably be done with this course. Okay, so let's go to homework problems. So for f of x is equal to 3x minus 5, and g of x is equal to x squared, find f of g, g of f, and their domains. All right, so everybody just post your homework answers. Also, I forgot to ask if you can see the screen or not. So can everybody see the screen? Yes, okay, very good.
Yeah.
So just post your homework answers in the chat for this one, and we'll see how you do. We'll go over it. All right, William. Okay, very good. So William, I'm going to have you volunteer to solve this problem. Would you like to do it?
Okay. So for the f of g, we do, since the g of since the g of x is x to the power 2, I think we just multiply x to the power 2 to all the x's. And I got 3x to the power 3 minus 5.
Are you sure it's to the power of 3? So instead of multiplying, you're going to replace all the x's. So it's just going to be the power of 2.
Oh,
Yeah. Okay. So now that you know, how about g of f?
so g of f is basically just, we just do f of x to the whole thing to the power of 2, and that is 9x to the power 2 plus 25.
Okay, so this one is correct. This one is good. So all you need to do is to substitute it in like so. Right? So what's next?
9x to the power 2 plus 25.
Minus 30, right? Minus 30x first.
Oh, wait. Minus 30x.
Yeah, it's like this, right? So this is negative 15x, then you multiply this. Remember, you have to multiply every term by every term. You can't just multiply 3x and 3x, and you can't just multiply like negative 5 and negative 5. So those middle terms also have to multiply.
Oh,
Yeah. So just remember that. It's minus 30x as well, plus 25. But this part is still correct. So if you think about it, right? If you think about it, 30x, 3x minus 5 times 3x minus 5, well, it's basically just distributive property, right? So it's 3x times 3x minus 5 minus 5 times 3x minus 5. See here, it's a little bit easier to see, this connection. You get it?
yeah.
Okay, so now we need to find the domain. Do you still remember how to do that?
Yeah. So the domain for both of them is just negative infinity to infinity.
Yeah, there's nothing really you can do here. If you just look at it, like there's no restrictions because both of these are they don't have any restrictions, so therefore the composition can't have any restrictions, right? So, all right, now let's look at this one, number 2. All right, and everybody post your answers on the chat. All right, so let's look at this one. Okay, so how about Kaylee? Let's have you solve it this time.
Okay.
So f of g, right? F of g, how would you do f of g?
That's 2, and then in the square root of 2x plus 5, and then that minus 1.
Very good, so you remember. Okay, how about g of f?
That is equal to the square root of 2x minus 1 plus 5. Oh no, 2,
2x minus.
and then 2x minus 1 in parentheses, and then plus 5.
So, like this?
Yeah.
Okay, this is cool. Very good. Then you can, simplify, right? Simplify 4x minus 2, that's plus 3, okay? And then we're all good. Very good job, okay? How about the domain? Do you still remember how to do the domain?
Yeah, it's like the intersection f of x and g of x, and then the f of g and g of x or something.
All right, very good. So, first you're going to find the domain of the result of this. And this is just that 2x plus 5 has to be greater than or equal to 0, right? So then x has to be greater than or equal to negative 5 over 2, right? Because, square roots. Then you have to intersect that with what? You have to intersect that with the
the
what do you
um
have to intersect with?
the domain of g of x and f of x.
Um, so for f of g would what will we intersect it with?
G of x.
Yeah, okay. So then, as you can see, the only restriction is it's just this. Yes, these are the same, right? Okay. Hold on. Gonna be like this. Okay. So what about the domain of g of f now?
Uh, is it negative 3/4 and infinity with negative 3/4 included?
All right, that's very good. Very good. Okay, good job. So that's how you find the domain. All right, so let's move on to the last one. This one, you have to remember about how we did those fractions, right? So remember how we did those fractions. All right, let's try to do this. How about this time, Zebo? Do you want to help? All right, then how about Eric? Would you like to volunteer for this one, Eric? Oh, someone's raising a hand. Okay, William. All right, William. Okay, William. How are we gonna do this?
So to find the f of g, we need to replace all the x's with the g of x. So I just first plug them in, and after that, I just multiplied everything by 4x plus 1. Wait, I mean, yeah, 4x plus 1.
All right, like so.
So, yeah. So now we can eliminate all the 4x plus 1s on the denominators. And then after that, we turn the plus 1 into 4x plus 1. And then the negative 2 to negative 8x. Yeah, negative 8x minus 2. After that, I just distribute the 2 times x plus 3, which is 2x plus 3. I mean 2x plus 6. So that will be 6x plus 7 over negative 7x plus 4. I mean minus plus 1.
There you go. Okay. So that was very, very good. So you used the technique that I showed you. So very good job. So because of the lack of space and we're running out of time in this, we're taking too much time on this homework problem. So we have to move on soon. So I'm only going to do f of g, but you get the idea on how to do it. So now for the domains. So real quick, let's just find the domains of f and g. So William, what is the domain of f?
So the domain is okay, so it's from negative infinity to negative 1/7 exclusive, or from negative 1/7 to infinity exclusive.
Okay, yeah, this is the domain of that. But what about this? What about the domain of f here? This one.
Oh wait, for that one?
Yeah, just real quick. Look at restrictions.
So that one cannot be 2.
Great. What about similarly, what is this? G now?
For that, it cannot be negative 1/4.
Good. So all we have to do to find this is we have to intersect the domain of G with the domain of this, which as you stated earlier, is cannot be 1/7. So this is x cannot be 1/7, x cannot be negative 1/4. And you get the idea. You can do the interval notation, right? You can do the interval notation. You already know how to do that. So very easy. Don't forget the union. Oops. Right, so like that. Okay, very nice. Let's go to our introduction to not polynomials, our introduction to exponents now. Okay, so you know what exponents are with numbers, but now we're going to introduce some algebraic concepts, to exponents. So let's say the b of x, right? So let me just make this really large real quick. So the b of x, let's just look at this real quick. So the b, the big number here is called the base, right? The big number is called the base, right? So you can do a lot of things with that, and it's very important later on. Okay, so now that's the big number. Next, we have x here is the small superscript of, like, that's the exponent, right? This is the exponent. This is the small superscript above the b. That is the exponent. So I'm sure most of you already know this. So what exactly is b to the x power? So if you don't know, b to the x power is just going to be b times b all the way to, actually, let me do this better. It's going to be b times b all the way times b. And you're going to do this for x times, right? So for example, if you take in, like, with real numbers, for example, 3 to the third power, right? This is the exponent, this is the base. Don't get them confused, right? That's going to be equal to the base, which is 3 times 3 times, it's going to be the base times itself for x times. X times is 3. So we're going to multiply 3 by 3 by 3, right? 3 times, right? So that's going to give us 27. So that's what an exponent is. I'm pretty sure you all know what it is, right? Brief definition. Okay, so now we're going to go over some principles that you probably might not know. Okay, so how about this? Put in the chat, what do you think is the something to the 0th power? What do you think is a to the 0th power? What do you think it is? So let's see here. Now that you thought a little bit about it, what do you think is the something to the power of 0? So let's see what people say. Zebo says 1, Kaylee says 1, Elaine says a, William says 1, and yeah. Okay. So you're correct, right? It is equal to 1. Some people might think it's 0, but it's not going to be 0. It's very strange. So I'm not too sure about the why something to the power of 0 is always 1, but you can always look it up online. There's many explanations. I'm pretty sure it has to do with the definition of exponent itself. But I like to explain this like how later on we'll come back after we know this. I'll come back and explain why this is true. And this is very nice because after we learn about negative exponents and simplifying, we'll actually be able to prove why anything to the 0th power is going to be equal to 1. So let's look at negative exponents real quick before we come back to the 0 exponent. So negative exponents, a to the negative n, assuming n is positive. So then negative n would be a negative number, right? Assuming n is positive. Okay, then what would that be? So something to the negative n would be the reciprocal of that, right? It would be the reciprocal of that to the n. Okay, so a to the negative n would be equal to 1 over a to the n, right? So then like b to the negative n, just 1 over b to the n. Okay, so if you have something like this, let's say no, that's b. Let's just do b then. B over c to the negative m, assuming m is greater than 0, then negative m is a negative exponent. Then what you're going to do is you're going to do 1 over b over c to the m, which is going to be equal to basically just c over b to the m, right? So that's what you can actually do here. So can everybody tell me in the chats what 2 to the 3rd power is? All right, so what is 2 to the 3rd power? 8. Very good. So then we know that 2 to the 3rd power is 8. What about 2 to the negative 3rd power? 1/8. Yeah, it's that easy. It's just 1/8. Okay, so let's just write that example down. So from this example, you can quite easily see how the negative exponent works. So now let's look at simplifying. So simplifying, what you can do here is if and only if you have a to the b times a to the c, what do you notice about this? And you notice that these bases are the same. So if and only if the bases are the same and you're multiplying these two identities together, what you're going to do is this is going to equal a to the b plus c. When you're multiplying these things with the same base, then you just add their exponents. Now, this is very similar with division. If it's a to the b over a to the c is equal to, that's just going to be equal to a to the b minus c. So if it's multiplication with the same base, you're going to add the exponents. If it's division with the same base, you're going to subtract the exponents. Okay? So it's very quite self-explanatory, but this only can happen with this if you have the same base. Now let's go back and show why a to the 0 is equal to 1, since we needed to know what negative exponents were and how to simplify. So to know how like a to the b divided by well, actually, let's think of it this way. Okay. So instead of using division, we can visualize it better with multiplication. So a to the b times a to the c is a to the b plus c. So what would a to the 0 equal? A to the 0 would equal a to the 0 would equal to a to the b times a to the negative b. Think about it, right? Think about it. A to the b times a to the negative b is just going to be to the b plus negative b, which is a to the 0th, right? But why does that still equal 1? Well, you see, a to the negative b is going to be equal to 1 over a to the b. So then a to the b times 1 over a to the b. Okay, this pen is getting weird here. A to the b times 1 over a to the b is just going to be equal to 1. That's a to the b times over a to the b, right? That's what a to the 0th is. Okay, so that's how you see why a to the 0 is actually equal to 1. It's a very nice proof. Well, not really proof. It's just a way you can kind of see it. So now let's look at some more principles that are more specified. So now let's look at this, okay? This is called power to a power when you have a to the b here, then to the c. All right, so chat, what do you think would happen if, what do you think this is equal? A to the b to the power of c. What do you think would happen with this? What do you think this equals? A to the bc. Very good. And then Zebo says a to the b plus c. All right, very good guesses. But a to the bc is correct, right? So when you have power to a power, all you're going to do is you're going to multiply these two exponents. It works with 3 similarly as well. If you have like a to the b, the c to the d, it's just going to be equal to a, b, c, d, right? So power to a power, it's very simple, okay? Now, how about product to a power? Now, okay, is when you have this. So how about let's do 2y squared to the 4th. Okay, that will be our example for later. So I'm going to explain this, okay? The product to a power. So let's say you have like a, b to the c. So what you're going to do when you have product to a power, and it only works with the product inside, right? Only works with the product inside. So what you're going to do is now you're going to kind of like distribute the exponent. It's going to be a to the c times b to the c when you simplify it, right? So now if you look at this and go to this example, this is basically just going to be to the 4th times y squared to the 4th. And we all know what this is. All right, this is going to be to the 4th times y to the 8th, right? So basically 16y to the 8th. Okay, that's how you do it. So what about x plus 2y to the 5th? All right, how do we solve this? What we're going to do is we're going to, again, distribute the exponents, right? X to the 5th plus 2y to the 5th. Can you do this? No, you cannot do this. Why? Because it has to be a product inside. So a lot of students, they misunderstand this, and when they see like x plus y is squared, oh, they're like, oh, so it's just x squared plus y squared. Or I think William, you actually did that earlier, right? What was it? It was 3x minus 5 squared, and you said, oh, maybe it's like 9x squared plus 25. All right, so this only works if it's a product. So if you have something like 3y minus 5 cubed, you can't just say like 3y cubed minus 5 cubed. Okay, you can't do that. It has to be a product. When this happens, you gotta actually multiply it out, right? You gotta multiply it out. This is actually what it's gonna look like. And as you can see, it's gonna be a lot more complicated than that. Okay. All right, very good. So now let's do some practice problems. We have like 15 minutes left, so about 5 minutes each problem should be fine. Okay. All right, so now let's solve this one. So let's see here. X to the 10th and y to the 6th. And then Williams also says x to the 10th, y to the 6th. So let's look at this, right? So what you first need to do is remember order of operations. So actually you have to do this first. So product to power, right? Multiply this 3 exponent to everyone here. It's going to be x to the 12th, y to the 6th. So that's all good. Now how about x to the negative 2nd? So what happens when you multiply x to the negative 2nd? 2x to the 12th, right? You add the exponents. So then it's going to be x to the 10th, y to the 6th. So very good job, guys. Let's now move on to this one. All right, so now let's solve this one. All right, b to the 4th times c to the 8th over a to the 6th. Very good. So I see, I think those are correct answers. So what you can do here is you can actually remember what I did earlier is you can actually flip the inside of this and turn this into a positive exponent. So what you can do is you can actually flip this. So now the b squared c to the fourth is on top and a cubed is on bottom, and this is a positive 2 now. So then you can very easily see that your answer is going to be b to the fourth, c to the eighth, and over a to the sixth. Or you can just multiply it out beforehand. All right. Let's do this one now. All right, let's solve this one. So this one you can't really flip. I would just suggest multiplying out first. So this is distribute the exponents, remember? That's going to be y to the 12th, z to the negative 8th, y to the 15th, and z to the negative 13th. So what you can see here is you can subtract these exponents, right? Because they have the same base. This is going to be equal to y to the 12th minus 15 times z to the negative 8 plus 3, which is y to the negative third times z to the negative fifth, which is just y, 1 over y to the third and z to the fifth. So that's all for today. Okay, thank you everybody for listening, and I'll see you next time.
Bye. Thank you.